All right, 8th graders, this is part 4. This is our last part. And you guys will be mixing equal masses, but of 2 different substances. So in this case, we are going to use hot metal in the form of washers, and we are going to use cold water, okay? So up until this point with parts 1, 2, and 3, since we've been using hot and cold water, but regardless water, we've assumed that when we say equal masses, we also mean equal volumes. Because we're using different substances in this case, it's not going to work exactly the same way because it's harder for us to find a volume of 3 washers and compare that to a volume of water like we've been doing. Okay, so this has a little bit different procedure as far as it goes. So what we're going to start off is I have my 3 washers hanging on just a string like this. And the first thing I'm going to do is get a mass of these, okay? Because again, we're working with masses over volumes. So we're going to continue working with masses over volumes as we have in the last one. So I go ahead, plop these on my scale, and I come up with 87.4 grams, okay? While I wait, what I'm going to do is I'm going to go ahead and heat these washers up. So I'm going to remember 87.4 grams. I'm going to go ahead and place these in my hot cup. There's nothing in there yet. And then I'm going to take my hot water and I'm just going to add enough to cover these washers. I really don't want to saturate the strings or anything like that. And I'm going to let those sit in there for a little bit with my thermometer. Because once the hot water heats up the washers, we're going to assume that the washers are the same temperature as the water. Okay, so I'm going to give that just a second while that heats up. And I'm going to show you guys what I'm doing with the cold cup. On the other hand, we've been using just a volume of water, but now we're going to actually need to use a mass. So I'm going to put my cold cup onto the scale. I'm going to zero that cup out. And I want the same mass of cold water as I had for my metal washers, which will be hot. So I am going to slowly pour cold water into here until I have 87.4 grams of water, which again is the same as I had with my metal washers. I'm going to do this kind of slowly because there's a little bit of a lag time getting caught up to where we're supposed to be. Okay, I'm about 61 right now, so I need to go about 20 more grams. And it's going to be close. It's not going to be perfect. I'll try as best as I can to be perfect. But again, my metal washers were 87.4, so I also want 87.4 grams of water, or at least as close as I can get. And I'm getting close. Oh, 87.7. So that's, of course it goes to 87.8. Let me see if I can just get a drop out. That might have been too much. 87.4. And drop. Okay, so I actually did that pretty good, 87.4. So now in my cup, I have 87.4 grams of cold water, and here I'm going to have 87.4 grams of hot metal. Okay, so I'm going to go ahead and move my scale out of the way so you guys can see this. So at this point, my washers have heated up. So one of the things you guys will record is the temperature of your hot water and your washers. So at about where it's at right now, we're going to assume about 65.0 degrees Celsius, okay? I'm going to take that out. I'm going to grab my hot washers. I'm actually going to leave them in there a second longer, excuse me. Let's get a temperature of my cold water. Okay. And just give that a second to kind of plateau so we know how cold our water is as well. All right, so we are still going down a little bit, but we are starting to slow down. So let's give it just a second longer to see if it kind of stays at a temperature for a little bit longer than it has been. All right, let's call it 8.4 degrees Celsius. I'm gonna go ahead and remove my hot washers, add them to my cold water, and I'm gonna kind of mix this up as best as I can. Okay, and we'll let it sit for a couple minutes and kind of see how long it takes, first of all, for the water and the washers to reach equilibrium where all of the atoms and molecules have the same kinetic energy and all of them are at about the same temperature. So again, from this, you guys got the temperature of the hot water, which we also assumed was the temperature of the metal. You guys got the temperature of the cold water. You guys should have had in there also on your table the masses. Okay, so what was the mass of your washers and what was the mass of the water you measured, the cold water. And now you guys can add to it the mixture, which should be your very last column. So it looks like we're stopped at about 13.9 degrees Celsius. So that should be your guys' final temperature of your mixture. And that concludes part 4. Let me know if you guys have any question on the data table.